Alright, let's take a look at this problem. Vertical order traversal of a binary tree. So we are given a binary tree and we have to calculate the vertical order traversal of the tree. What do I mean by that? Let me maybe just show it to you by drawing. So um, let me check if I have to, there might be multiple nodes. Alright, so we can have 5 different cases, but just before that I want to go over the output of this. So as you see, for the -1 column, so columns are like this, okay? Columns are like this, vertical lines, if you just draw them you can just see it. So these are representing the columns, and these are. So when you go right, you're increasing the column. When you go left, you're decreasing the column. And we'll be using that in our recursion. And because of that, at the end, we will be having this type of result list, list in a list answer, and we will just return that. And for that, for this problem, we can immediately think about traversing. We want to go over it. We can use breadth first search or depth first search. I prefer using depth first search, and because we don't care about the levels, because it's the question also asks us to return the when they're like equal. Let me just maybe show it to you here. If you have like 17 here, this will be 2, 0. In this case, the question wants us to return 15 first and then 17. So for the zeroth vertical column, we should just return 1, 0, 15, and 17, like this. And because of that, we have to, no matter what, we have to sort it. So even if we use the breadth first search, like we go this way, we go then this way, in that case we again still have to sort this part, so it doesn't matter which one we use. So I want to stick with the depth first search. So anything else I want to add here? So here, as we see, in this case we want to return 1, 2, 3, 4, 5. So we want the column values to be sorted. So that's why we'll be using sort function. And we can just go over this like the first search way. So let's start. So what do I need for this? By the way, I'm planning to have a structure with a dictionary like, so I will have a dictionary. My key value will be my column. So I want this, and I will have a list of tuples where I have my root value, or like node value. Let's put it that way. I want to have my node value and also my row, but I want my row to be at start because I want to sort it based on my rows. So when I have these 3, I want to sort them according to their rows and then their values. So I'll have a structure like this, and I'll go over this like that, and I'll create my dictionary with this structure, and then I'll also hold the minimum column we have and the maximum, and then we just go over it with a for loop, just go over everything, every column with a for loop, and then just construct the output as we need here. All right, so let me just start. First thing is that okay, I'm gonna need some like result to return. I'm gonna need to store the minimum and maximum, and the best way to do that is to create a class of tree info, and then we define like this self minimum column we have a start, it will be 0. Maximum column we have will be 0 start, and then we have to create that. So my tree info class should be equal to, okay, like this. I don't need a parameter in the constructor. So, and also I'll need a dictionary to and for this I'm going to use default dictionary where we have list, and because of these I have to import so from collections I have to import default dictionary, and okay, that will be fine. And then I will call my differ search function with root, my column, actually my tree info, my dictionary, and my column and row. Okay, and then I will just define this here. I'm gonna pass tree info the same way, names are same. This will be row, this will be column, and then if we have a root, we want to continue. If we don't have a root, we can just stop. We don't have to do anything. So when we have root, we basically have to change the tree info, and also we have to put the current column's value into a dictionary. So dictionary column, we should just append to this. Like I said, we first have to put the row and then the value, because when we sort them, we want it to be in that order. We first want to sort based on the row. The second element will be taken when they are equal. When we have same rows here, as you see, we have 2 and 2. In this case, we'll just sort it. Even if we had like 6 and 5 here, we will still get this output because we will be just sorting them with this tuple structure. So then we have to, if we just reach, if the minimum column changes, we have to update it. So we take the tree info and we will just take the minimum column, and then we just have to take it like this, and then we just have to make it like change it this way. This should be also max. This should be like that. So we update the maximum column values we have. So at start, we will start from this. When we go here, as you see, we will have -1 in our dictionary. So when we have that, we want to also store it into in somewhere, and that somewhere is our class here, because I did it like that. We could also use an array to store, or we could also use non-local keywords for that, but I think this is the more appropriate way of doing this. So let's see. At this point, we also want to traverse. So we want to call root left. We want to go left. We want to use the same import tree information, same tree. The row should be +1, and the column, when you go left, column should be -1. When you go right, column should be +1. Row also increases. We use the same values, and then we should just traverse right. And after this, we will have a dictionary, and we want to go over this dictionary. Yeah, and so here this will be column in range. So we have to get tree info, that's min column, like this, and then tree info max column +1, because it's exclusive. So yeah, we want to include the max column. We want to also take those elements in the last column. So we have the +1 because of the range function we have. All right, so at this point, we want to just append to the results. And what want to append. I want to append the values for every. So this is row. The first one is row. I will be taking from this dictionary. So maybe it's better to show it like this. Row value. Actually, I made a mistake there. Value in for okay. Yeah, like this. For in dictionary and column. Okay, we just take the columns here. First, we will just take this one. Okay, we'll just delete this. Okay, we just take this one, and then we just go over it and append to the results like this. And then we go over the second one where we have this. We just append it to here like that in the results, and then we go to the next one. As you see here, I just forgot something. I should be sorting this. Okay. Okay, I just sort this because, like we say, after row we have to look at the values. If the values are 6 and 5, we still want to return this, so we have to sort that. Okay. 1 second. Okay. Right. Let's see if this works. Okay. Yeah. Great. It works. So like I said, we will just reverse over this, and then we have to put store the columns as keys and row and values as tuples in a list. And later on, we just have to go over this tree like this within the boundaries of columns, and then just append in a sorted way because we want. I mean, the question asks that. So in this way, we will just have our answer, and the time space complexity will be okay. DFS will be of n. We'll just go over every element once, and then here, as you see, we will just go over minimum and maximum, and then we'll just sort it based on how many items we have on that column. So for this, we can just say that I think it will be in the what will be the worst case if we have something like zigzag like this. In this case, we will need half of it sorted and second half also sorted. So I think this will be yeah, I think this should be, the time should be of n log n because we sorted. In the worst case scenario, we sort the n divided by 2, so the time and space complexity also stays the same. So the space is, in the worst case scenario, if you have something linear, if you don't have, in the binary tree, if we have something like a linked list, in that case, we just have, for the recursion, we will have O of n, and for the result, we return every element. So because of that, also we have O of n. So when we sum them, it will be just same. Actually, we have to sum. Yeah, even if we sum it, it is just O of n, the space complexity. So yeah, I think this will be my answer to this problem. It's a quite nice problem. Just makes you think different things at the same time. Yeah.